Okay, so like you read about probably in the section of the text here, the second derivative, if derivative means rate of change, so here's where it gets really fun. The second derivative, if you just take the derivative again, tells you the rate of change of the first derivative. So if the first derivative tells you whether something's increasing or decreasing, the second derivative is telling you how fast it's doing that, or essentially, is it increasing at an increasing rate, meaning getting steeper and steeper, or is it increasing at a decreasing rate, getting less steep, but still going uphill, right? It doesn't change whether the slope is positive or negative. Or if it's concave down, is it increasing at a decreasing rate or decreasing at a decreasing rate? That's fun, right? All right, so what helps is to look at kind of the four options that can happen here and think about the shape of them. So if we've already seen concave up and down means essentially, does it open up? There's a lot of analogies, like, you know, if you put water on it, would the concave up would kind of hold water in it, like a little contact lens or something, or a cup, depending how, you know, how up it is. And concave down, it would spill off because it's like a little downward curve. And then we already know increasing, decreasing, right, is a positive slope is uphill, could be steep, could be not steep, and a negative slope is downhill. So now if we're thinking about what these things would look like, so let's say increasing and concave up. It's increasing, so going uphill, and concave up means it's increasing at an increasing rate, so getting steeper as it goes. Sometimes it helps to picture like a little stick figure guy. You're climbing up this hill, right, from left to right, kind of the way we read. See how it's getting harder as you go? Right, it's increasing at an increasing rate. It's increasing, but it's also getting steeper and steeper and steeper. It's turning into like, you know, a slightly curved wall, like Ninja Warrior or something, down to like something that's perfectly vertical, or starting to approach vertical, I guess, not perfectly getting there. So increasing at an increasing rate is uphill, but steeper and steeper as it goes. All right, so then what would increasing at a decreasing rate look like? We still need to be uphill, but now it's getting less steep as it goes. So notice here, right, starting out, it's steeper. This whole thing is still increasing, right? It's still a positive slope, and so is this one, but it's decreasing at a decreasing rate. So this is like you're topping out the top of a hill. You know, it's really, really steep, and then as you approach, it's starting to flatten out. It's kind of getting easier as you go. And then there's, all right, so what if we're going downhill? Maybe we'll change colors for downhill just for fun. So now we're decreasing. All these have to be decreasing, but we're still going to go concave up and down. So decreasing, concave up. Still going downhill, but at an increasing rate. Now the increasing is weird to think about. Is a little bit concave up, right? We know kind of like it has to curve upwards. Is a little bit weird to think about because positive, negative numbers come into it. But notice how this is decreasing, so it's going downhill. And then concave up, it's doing it at an increasing rate, meaning it's getting closer and closer to positive or closer to zero. So I know it looks like less steep, but this is the reason why, right? Is because if this is a steep negative, like if the slope is -5 over here, maybe the slope is only -1 by the time you get to here, and the slope is getting closer to zero. So since we have a negative slope, an increasing rate means that it's getting less steep. A lot of stuff to wrap your head around. Also, what helps is just to look at it, see how it's downhill and it curves concave up. And so then our last option here is decreasing concave down. It still has to go downhill, but it has to be concave down. So it's downhill and it's getting steeper as it goes. So like this one maybe, we'll put our stick guy on this one. Like this one would be good for sledding. It bottoms out at some point. This one would not. You're like gonna fall off a cliff. So here's our four options and kind of how they all look together. So also if they start giving you graph information, they tell you stuff about the slope and the concave up, concave down, we should be able to get a decent picture of what a graph might look like just from that information, because we kind of only have four options and we kind of start sticking them or like gluing them together. All right, let's see if we can get a function here. Maybe I'll just move, or I'll zoom this out a little so that we don't lose our choices. Put that stuff in the corner. Okay, So let's say we have a function where f of 5 is -4. I don't know about you guys, but I really like when they give me a point. It's something, at least something concrete. The rest of it is just kind of like a general behavior of the graph. And then they tell us the slope at that point is 1. So we know it's uphill, positive, right? Like a 1/1, it's kind of up 1/1, like some little steps or something. And then they tell us the second derivative at that point is -1. Second derivative tells us whether something is concave up or concave down. So I know the second derivative is negative, and also it has to be shaped concave down. Sometimes just these little notes like this can be super helpful, like just something to remind you, like this means uphill, and this means concave down. Just like draw a little concave down picture. Okay, so let's see what that might look like. So 5, -4, 1, 2, 3, 4, 5, somewhere right, -4 is, you know, a point somewhere in this region. This is what I mean about I like a point. It's like a concrete piece of information. Okay, so we have a point, and then we know it's uphill at that point, and it's concave down. So what would our uphill and concave down? Uphill and concave down is like this kind of shape. And so that's just at that point. It doesn't mean that it can't change behavior. So at this point, it's doing something like this. You know, who knows, after that it could go crazy. I'd say when you look at the answer choices, they don't go that bizarre. They often have you choose between like a bunch of different parabolas, right? But technically the graph could be anything. All we know about it is that at this point, it's this kind of shape. It's increasing, so uphill, and yet still concave down. And so I'd say out of the answer choices they give you, it's likely to be something like this, maybe. That would work. And so notice we're only talking about it at this point. It's still increasing in concave down. Over here, it's decreasing in concave down. But they don't talk about what happens after that. We just need one that has the right behavior at this point, because that's all we know about it.